Hello, welcome to the fourth unit Multivariable Differential Calculus and Function Optimization. In this video, we are going to see about functional dependence. Let us see first the definition. If u, v, w are functions of x, y, z and u, v, w are not independent, that means they are dependent, then the Jacobian of u, v, w with respect to x, y, z must be 0. So that is, whenever u, v, w are dependent functions, then definitely the Jacobian must be equals to 0 with respect to the independent variables x, y, z. Now we'll see this by problem. Prove that u equals to x plus y by 1 minus xy and v equals to tan inverse x plus tan inverse y are functionally dependent and find the relation between them. Okay, so u and v are given. We have to show that they are functionally dependent. That means we have to show that the Jacobian of u and v with respect to these independent variables x and y must be equals to 0. Once it is 0, next we have to find what is the relationship existing between these two. Okay, so u and v is given. So we have to calculate this one, Jacobian of uv with respect to xy. For that we require 4 derivatives, u sub x, u sub y, v sub x and v sub y. This is v, it's a printing mistake, v sub y. Okay, so first u sub x, partial differentiation of u with respect to x. So it's a quotient rule we applied, 1 minus xy whole square, 1 minus xy. For x plus y it is 1 minus x plus y. For 1 minus xy with respect to x it is minus y. So if you simplify this, 1 minus xy minus of minus plus xy, x minus xy plus xy gets cancelled, minus of minus y, y square becomes plus y square. Similarly, uy you will get 1 plus x square by this. Next, vx, partial differentiation of v with respect to x is, for tan inverse x it is 1 by 1 plus x square, tan inverse y is 1 by 1 plus y square. So we substituted all this here. Okay, so if you simplify this, 1 plus y square, 1 plus into this becomes 1 by 1 minus xy whole square. Similarly, 1 minus 1 plus x square, 1 plus x square is cancelled. So left over is minus 1 by 1 minus s, which is 0. So the Jacobian is 0, means u and v are functionally dependent. So since this is 0, therefore u and v are functionally dependent. Now we have to find what is the relationship existing between them. We know that in our intermediate, tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy. Given that tan inverse x plus tan inverse y is v, therefore tan inverse of this is given u. So what is the relationship existing between them is u is tan v. So next u is this, v is this one. Then find Jacobian of uv with respect to xy. And he's asking, are u and v functionally related? Okay, so they are functionally related whenever the Jacobian is 0. So u equals to x plus y by x minus y, v is xy by xy, this is given. So first find the relationship, Jacobian of u and v. So dou u by dou x, dou u by dou y, dou v by dou x, here also dou v by dou y. Okay, so 4 derivatives are calculated here. We substituted the 4 derivatives here, right? And if you simplify this, so x minus y whole square into x minus y whole cube became x minus y whole power 5, 2y into x plus xy. So if you observe, this is 2xy into x plus y, the same thing we got, which is 0. Therefore Jacobian is 0, means they are functionally related. Next, to show that the dependent variables in the following transformation are functionally dependent and also establish the relation. So we have to show that this UVW are functionally related. That means we have to show that first the Jacobian of UVW with respect to XYZ is 0. So UVW is given. So according to the formula, U sub x, U sub y, U sub z, V sub x, V sub y, V sub z, W sub x, W sub y, W sub z. U sub x. U sub x means partial differentiation of u with respect to x. So when you are doing with respect to x, y and z are constant. Therefore, it is e power y sin z. Next, with respect to y, if you are doing, x sin z as it is for e power y, e power y. When we are doing with respect to z, x and e power y as it is, for sin z it is cos z. Next, v with respect to x. So e power y cos z as it is, for x it is 1. Next, with respect to y, x cos z is as it is, for e power y, e power y. Next, v with respect to z. So x e power y as it is, for cos z minus sin z. Next, w with respect to x is 2x e power 2y. With respect to y, x square as it is, for e power 2y, e power 2y, for 2y it is 2. Here there is no z term, therefore w with respect to z is 0. Now we have to expand this one. So in the first row e power y is common, in the second row also e power y is common, in the third row e power 2y is common. So clubbing together e power 4y. So rest is sin z, x cos z, x cos z minus x sin z. So here 2x, here it is 2x square 0. Now we have to expand this one. So here, if you look at here, in this row, x is coming out as common. Sorry, in this column, x is coming out as common in this second column. In the third column also, x is coming out as common. So that x into x becomes x square. In this row, x is coming outside, 2x. So 2x cube totally, that comes outside. So leftover is sin z, cos z, this one. So if you expand on this third row, clearly you will see the determinant is 0. Therefore, u, v, w are functionally dependent. And what is the relation between them means, if you square u square and v square, then what happens is x square e power 2y is common. So within brackets, you will see sin square z plus cos square z is 1, which is 1. So you will left over with x square e power 2y. What is x square e power 2y? Which is w. Okay. So this is the relation. Next, the fourth one, if you see, if u is x square plus y square plus z square, v is this, w, show that they are functionally related and find the relation. u, v, w is given. So the Jacobian we calculated. So we got 2x, 2y, 2z, y plus z. So what I done is, I taken this 2 outside and I added row 1 with row 2. So I got x plus y plus z. In the next step, I taken out x plus y plus z. So we left over with 1, 1, 1. Because in a determinant, if two rows are equal, so it is 0. So they are functionally dependent. So what is the relation? We know that x plus y plus z whole square is this one. But x plus y plus z is given that it is w. W square is, this is given as u. And this is given as v. So w square is u plus 2v. That is the relation. And one more problem is here, u, v, w are given. We have to show that they are functionally related. That means the Jacobian of u, v, w with respect to x, y, z, we have to show that it is 0. Next, we have to find the relation. So u, v, w is given. The same formula is applied. So according to the formula, u sub x is 1, u sub y is 1, u sub z is 1. With respect to x, for v it is 2x minus 2y minus 2z. So like that you will get the 9 derivatives. So in the second row 2 is common, in the third row 3 is common. So I taken out, so it became 6. Next I applied C1 minus C3. So we got this one. Next C2 minus C3, we got this. This is just for the comfort of evaluating the determinant, I subtracted. Okay, now I got 0, 0, 1. So on this row, if I expand, right, clearly see, before expanding, what I done is I taken here x minus z as common outside and here y minus z as common outside. Leftover is this. Now if I expand this on the first row, right, so easily I can see it is 0. So therefore they are functionally dependent. And we have to find the relation. So what is given, u is this one. What I am doing is I am squaring this. U square is x square plus y square. So u square, I am adding for this v. V is given for us. V is this entire expression. If you add this v to u, you will get this one. So from this x square plus y square plus z square is this one. So I am naming it as 1. Also given v is this. So from this v equals to, just now we calculated what is this, x square plus y square plus z square. I am substituting here minus 2 times of x plus. From this I am calculating this one. So which we are naming it as 2. Now w is given this one. So this is a familiar formula, x plus y plus z into this. So x plus y plus z is given as u. This is from 2, from 1, this is u square plus v by 2. This is from 2, u square minus v by 4. So if you simplify, you will get this one. So this is the relation between uv and w. Okay. So these are the simple problems. Okay. I'm Srikanth Reddy. Thanks for watching. I will see you in the next video.